Okay, good morning, everybody. Are you all ready? Okay, so welcome to Dreamforce, and my name is Kripanandan. I'm a success specialist with Salesforce, and just wanted to thank you all for coming to this session. Anybody first time Dreamforce here? Okay, oh, that's a good amount, so thank you all for coming, and thank you to our returning trailblazers who are here and making this community great. Really appreciate it. So we are in for a great session here. And if you're really interested and looking forward to learn about Einstein Insights, I think we have this is going to be a great session for you. We have two amazing speakers here, Jeremy and Milind, and they're going to really walk you through to, from the basics to all the way how to integrate with Einstein. Okay, so. I know those of you who have been in Salesforce sessions have seen this slide many times. You're going to see this hundreds of times over the next couple of days. But the main thing is obviously if anything that's discussed here that is future-facing, that is not generally available, make sure you're aware of that so that you don't make any decisions based on that. Okay? With that said, I'm going to hand it over to Jeremy and have a good session, guys. Thank you.
Hey everyone, I'm Jeremy Whittington. I'm the CEO and founder of Thinkaholics. We are a Salesforce consulting firm based out of Dallas, and we focus on Salesforce implementations and integrations.
And my name is Milind Borkar. I'm the founder and CEO of Illuma Labs. We are a machine learning and signal processing startup based out of Dallas as well. So I'm going to start off the first half and hand it over to Jeremy. Before I get in, just to kind of get a gauge of audience, how many people here are actually familiar with Einstein, have actually played around with it? Yeah, that's good. How many developers actually done something with the platform services? Okay, small, good, okay. Would love your feedback later on as well in terms of what you guys have learned. This is our time to share some initial exploration we've done, and hopefully our experience can help you guys moving forward as well. Do want to join Kripa in thanking everyone for being here. 8:30 a.m. on a Monday, especially after flying in and meeting all your customers and partners for the first evening, which sometimes ends up going a lot later than planned. So appreciate everyone being here bright eyed and early. I'm going to start off by just introducing AI and Einstein at a very high level. I'm not going to go too much in depth, but basically just kind of carve out and say, this is what overall AI looks like, but this is what Einstein's essentially intended to do. And then we transition over to platform services, looking at a little bit more from the perspective of what a developer can hope to achieve by doing custom development with the APIs available. And then Jeremy is going to walk through a demo that's been put together and show some interesting items that we've learned along the way. And then takeaways and Q&A. So AI is here. I've seen this message sort of used in a variety of different forms and really set up hyperinflated expectations from people. I've seen marketing completely oversell what AI can do today. I've seen customers, senior management come up with really high expectations of what it can do. The general expectation I've seen for people who are 2 steps removed from the actual implementations or usages of these products is converging towards what's called strong AI, right? Which is basically the ability of a machine to make decisions or solve problems kind of indistinguishable from what a human would do. So obviously we're not there yet. I expect that'll be several years before we do. But what's good today with AI is what they call narrow AI, which is essentially using software to solve very specific problems and gain insights. Typically, this can be done way better than humans can do, just in terms of the ability to process data that a machine can provide. And that's exactly what Einstein does. So Einstein is essentially Salesforce's answer to AI, and essentially a very targeted implementation to make CRM better user experience, essentially for your customers as well as for your internal teams. So Salesforce is integrating Einstein into a variety of different platform tools that's available today. The nice thing is you can use the powers of AI and machine learning without having to be an expert in any of the underlying tools. very nicely packaged product, which includes things like deep learning, predictive analytics, natural language processing, without having to have core expertise or PhDs and data scientists on your team. So we'll talk a little bit about that in terms of what's abstracted, as well as what kind of features you can hope to achieve with the tools available from Einstein. So as a developer, what could you do? As I mentioned, Salesforce is integrating Einstein in standard platforms, but the focus here is your customer needs a specific type of implementation and wants to leverage capabilities of Einstein for specific applications that are custom to them. We as developers want to service that need. So what can we do here? So platform services is what we'd use, broadly classified into two main areas. There's Einstein Vision, which is more of a computer vision set of APIs, primarily targeted towards detection and classification of objects in images. The other one is Einstein Language. This is where you'd have more of a text-heavy interaction and helps you with detecting sentiment and intent of the actual message underlying the conversation. Looking a little deeper, and giving a little example about how you could use vision, in typical literature, you'll see lots of pictures of dogs and cats, but I kind of wanted to keep it a little bit more applicable to what might be, real use cases seen out there. I spent several years at a Fortune 500 semiconductor company, so I put an example that makes sense for me, and a real pain point I had in the field. We spent a lot of time trying to find opportunities and hunting for new sockets with our customers. Sometimes we'd get, a board level drawing. Sometimes we'd actually be able to get, buy a product like this from something off the shelf. And the goal was to figure out what kind of opportunities exist for us, what can we not go after, and really tailor our strategies for hunting. This was a really painstaking manual process, which is really error prone. If you look at that board, there's so many different components on it. To be able to look at each one, tabulate them correctly was, just error prone, but also a complete waste of the sales engineer's time. So if having something like object detection and classification capabilities, you can imagine having functionality where the image itself can be automatically assessed by the application and pulling out not just where the different opportunities are, but also classifying them in terms of which ones we may have a pin compatible fit for, and which opportunities should we maybe consider for the next generation roadmap. Various applications like this could be used for your particular end use case. From a sentiment point of view, if you have a text-heavy interaction, maybe email or something of that nature, Einstein Language is able to tell you the general mindset of the customer. So combination of positive words and negative words. In this image, it shows words like, the negative intent is with words like renounce, dissent, refuse. The positive intent comes from more positive words. Einstein has a little bit more capability than just looking at word spotting. It looks at sequences, patterns in the language to determine if the customer's in generally positive mood, negative mood, or neutral or unknown. The other thing you can do with language is determining intent. So customers, request is coming in. Are they talking about product availability? Are they talking about pricing? Are they talking about some sort of a technical support issue? Using these two together can help you route these requests to the right person. VIP customers potentially go to a different type of agent, and maybe shipping goes to shipping and so forth. So here's the cool thing about Einstein, where, as I mentioned, you don't need to know anything about the underlying systems or the models. You do have the responsibility of collecting the appropriate kind of data, and there's simple calls to be able to train the underlying models with the data you provide to it. The goal here is once you train your models, you can pass in any kind of test data. In this case, it says classify data to generate either classification or a prediction. So what this example is showing is when you have very similar data, you have very similar data points to what you've actually trained your model on, you can end up seeing fairly accurate results. But obviously, if your data that you originally trained your system with is not well represented for any new data coming in, you actually may have a very low probability response coming out. So fundamentally, it's how much data you train it with, and the quality of data you train it with is important, but don't need to know much or anything about what's happening underneath the hood. Looking at a more vision-centric example, Here we show a very simple example with object recognition to determine the difference between 3-door refrigerators and 2-door refrigerators. So you give it large enough amount of data, different types of models, different angles, maybe some obfuscated, some with other content around them, some images with just the refrigerator alone. Sufficient enough data to train the model, but then when you put in something which it may not have seen before, has enough knowledge to be able to tell you with what probability a particular classification comes out. And you can use these tools to build any kind of applications for your customers. Similarly for language, there's a little bit more labeling that's required because Einstein does provide the capability to detect intent as well as sentiment. Here you'd be able to provide customized labels for your application. I know this might be a little harder to read, but I can say, for example, the first line says, I'd like to check the status of my order. So that's obviously a shipping-related question, so you label it as such. How can I switch my billing preferences, which is obviously a billing-related question, and so forth. Provide, again, sufficient amount of data to be able to train the system to classify for the specific classes that you use in your application. Train models, and then you send in any future requests which may not exactly be aligned with what you've already trained for. So here, request, I'm tired of waiting, where are my shoes? It's coming back with a 70% probability that this is a shipping-related question, and obviously the sentiment here is negative. And Jeremy will be able to walk you through a more real-world example of how we've tested this out with some data. On that note.
Yep. Thanks. Okay, so what I'm going to do right now is just walk you guys through, a scenario that we set up to show you how to use Einstein Intent, as well as combining that with real-time data. So for the demo, what we've done is we've kind of come up with a fake P2P lending network business. So essentially, when someone comes to our websites or landing pages and is looking for a lead or is looking for a loan, the lead gets submitted into our company, and based on what they've told us, based on what type of loan they're looking for, as well as some of the real-time data I'll go into, we'll route it to the correct lender that's appropriate for what they're looking for. All right, so we've set up a web-to-lead form, simple Salesforce web-to-lead form, and I'm going to actually show you guys this all working. So on there, we just get information from them, as well as have them kind of tell us in text for the purposes, of highlighting Einstein Intent, what kind of loan they're looking for. So we are essentially, based on what they say, trying to classify what they're looking for, right? So whether it's a home loan, an education loan, a car loan, a personal loan, using Einstein Intent, you can, based on the text itself, figure out what type of loan they're looking for. And the real-time data piece here is, if someone's looking for an auto loan, for example, we may want to call the FICO Auto Score credit score service to get their credit score for automobiles. If they're looking for a home loan, we'd potentially call Beacon, or FICO, or something generic like Experian or something like that. So, kind of combining this together, we first kind of classify what they're looking for on the loan type, and we combine it with their credit score, and we're essentially routing it to the correct lender within our system. All right, so going to go a little deep here on code real fast, and this will work into the demo, and then I'll actually show you guys some code. So the first thing that you need to do in order to use the Einstein platform services is to sign up. So once you go to their sign-up page, you would provide either a Salesforce login or a Heroku login, and that will get you access to the Einstein platform. You can try it for free. There's free licenses that you can use if you just set up a developer org, or if you have your own Salesforce licenses, the amount of API limits will be tied to what you guys have purchased for Einstein. So after you sign up, it gives you a private key that you need to download, and you need to make sure you save this file because I have not figured out a way to get it again, so don't lose it. This file will be used, I'll show you, it'll be used to basically log in either programmatically or, if you're just testing stuff yourself through the browser. So if you were to go through the browser method, you go to their token page and you would get, you put your email in, you'd upload that file I told you about and specify how long you need a token for, and then you can use this OAuth token for the remainder of your calls. All right, so getting started with it, especially the documentation, you're going to be basically just making calls to a REST service. So their documentation gives you what you need around using CURL to just make calls directly to the REST service from your computer. This is how you will basically upload your data that you've collected to train your models, as well as the interface for training and all of that kind of stuff. I'm sure there will be more friendly UI-based stuff coming out as everything progresses, but this is the interface that you would be using by default. So there's a couple pieces within the call that you make. You put the token in that you got from that token service, and then you specify the path to the data that you want to upload, and then everything else is just the standard stuff that you pass. So once you have your data uploaded and it successfully uploads, then you will essentially train your models. So you pass this code, or you pass this command into the REST service, and you essentially name your model that you're going to use, and you can create multiple models even off of the same data. And then you specify the data set ID that you got when you uploaded it. So what this will do is this essentially does the training of the actual, the models themselves. All right, so let's get into just showing you guys this working. Sorry, it's a little hard to see the screen. There we go. Okay, so this is our web to lead form. So we've already kind of loaded a few leads, but I just wanted to get something from you guys. So someone that's close here where I can hear you, tell me what kind of loan you'd want, and I'm going to put it in there. So anybody? Small business. Small business? Okay. And what's your first name? Mary. Mary. So I've typed in that I'm looking for a loan for my small business. Okay, so that did a Salesforce web to lead form. All right, so one more. Anybody? What kind of loan would you like to get? Auto loan. Okay. And what's your first name? SAT? SH. So I said, buying a new car and need to finance for 4 years. Okay. All right, so let me log in to my org. We'll take a look at what happened. Okay. So I cannot read that. Okay, so. Okay. All right. So the Satish, basically said he's looking for a auto loan, and so as you can see, the loan type is auto. We were able to detect that based on the text that he used. His credit score, which is obviously not realistic, is 437. So
is that accurate?
So he got routed to the Pelican Auto Finance. And I hope you guys can see this, but this is the, let me just do this. This is what we got back from Einstein. So as you can see, so it was a 93% match for car and a 3% match for major purchase. Okay. We'll just look at one more just because I want to be conscious of time. So we'll take a look at Mary's. All right, so Mary had asked for, looking for a loan for small business. So this one we did match as a small business loan, and it was at 83, if that's very hard to read, 83% match to home loan, or sorry, small business loan.
And the worst credit score than Satish.
Is it? Okay. Okay. All right, so let's talk code here. So give me just a second. All right, so for this demo, what we did is we set up a process builder that anytime a lead comes in from our landing page, we basically fire off a Apex class that makes the actual call out to Einstein Intent, and then turns around and updates the lead with the probability match that came out. And then at the bottom we run the lead assignment rules that we fire off the lead assignment rules to route it to the correct person. And one thing I didn't mention is we also at the same time make a call out to the credit score service to get the credit score for that person. Obviously it's demo, so it's just all mocked up, but just to show you guys kind of how that works. So let me talk briefly about the code that you get from Einstein. So give me just a second. Okay. So once you sign up for Einstein and you get the documentation, I hope you guys can see that. They give you a couple different classes that you'll need to call Einstein. This is stuff that you can write on your own. You don't have to actually use the code they gave you, but it's a nice way to get started very quickly. So the first one is the JWT bearer flow. So this is just the code for calling the token service to get the token that then your code would use to call for everything else. They also give you they give you a vision, but just to show you the language, so they give you a language class that has all the code that you would need to call the actual language REST services to predict an intent or sentiment. And so jumping back to my code real quick, if I can see my mouse. Let me just pull it over here to make it bigger, I'm sorry. Hopefully that's a little bigger for you guys. All right, so the first thing that we have is the invocable method that the process builder process would call. And for that, we are essentially passing in just the IDs of the leads themselves. From there, we make a asynchronous call, and it needs to be asynchronous, so you do an @future call to my code that I wrote to call Einstein Intent. And it's pretty basic. I wrote a little utility class to get the token itself. So I call and get the token, and then I call and get the lead information, taking the IDs and getting the information for what they said in the lead in the web to lead form. And then I just loop through and I call the Einstein Intent process. As of this moment, I'm not aware of a way to call it in bulk. It does appear through the interface to require you to call it one at a time. I'm sure that's something that will be coming, though, to do batches instead of single calls. But that's just my guess. I would imagine that that's the direction they will head. But anyway, so we loop the leads and we call the Einstein intent to get the actual predictions back. And as you guys kind of saw, it was a JSON string that comes back and gives you the different labels that matched and what their probability score was. So from there, based on what Einstein predicted, we call the different credit score services, and then update the lead with all of that information, and then, as I said before, fire off the lead assignment rules. Give me just 1 second to get back to the presentation. Okay. All right, so I believe these slides will be publicly available for you guys, but some of the key things, resources to take away here is the Einstein sign up, right? So that's where you go to just get access to Einstein itself, the token class to get the authentication, and the documentation itself. I also put a link in here to the data we use to train our models. It's publicly available. I believe it was University of Pennsylvania is the one that collected all the data. But that's basically what we use to combine. All right, so if anybody has any questions they'd like to ask, we can kind of go deeper and either look at code. And there's a mic right here, if you could.
Hi. First the question is how Einstein Intent leads with different languages. Mm-hmm. Do we have to build a model and send to him how this process works? Because the examples are very simple, right? You see small business, you see car. Mm-hmm. What happens if you have other languages? Yeah.
So, you can train multiple models, right? Overall, you'll need to experiment with what gives you the best result. But you can upload, right, a data set that has all your data together, right, in different languages and train a single model. Or you could upload multiple data sets and train different models. And then, based on, where the lead came from, right, in my scenario at least, you could target the different models to do the sentiment or intent. It's a good question, though. Thank you.
When she had said, what was it, small business loan, and it showed the probabilities, where did the other results come from? Why would it think on any planet that loan consolidation is a probability?
Yeah. So let me pull up what I typed in just to kind of show you that. So overall, is that the right one?
Yeah.
Okay. All right. So what she said is, sorry, I'm copying it here. Yeah, I can't copy it. So what we wrote is, I am looking for a loan for my small business. So just pulling up those probabilities again. So if you think about what people say, right, whether I'm saying a car loan or an auto or a home loan or something like that, I might say I am, or there's other texts that's a part of what I said that do have some matches on the other labels that I've defined. So this is the wrong probabilities, but we'll just use this one as an example, right? So this was the car loan example that we used. So wedding was one of the labels that came up, and it was only a 1% match, right? So just based on what people said on when they were asking for a wedding loan, some of the words kind of overlapped. But as you can see, right, the 93% for a car, right, and the next lowest down is 3%. So it was able to hone in on the pieces about the auto loan to show you that.
But it's comparing it to previous questions. Is that what
Yeah, I don't know how well you guys can see this, but I'll just show you some of the data real quick. Also, I have another session tomorrow where I'm going to dive into how I prepped all this data and loaded it in. So that's at 11:15, I think. Is that right? Anyway, if you're interested, just let me know. So anyway, it's kind of hard to read there, but this is the data that we got from UPenn, and as you can see, the person that captured the call, there's a lot of things that they said during that conversation, right? And sliding to the right here, if I can. Sorry, I can't see my mouse. Okay. So just sliding to the right. So what this data had is the actual labels themselves, right? So what the person said, and they wanted a car loan. So we trained our models using this data. So for you guys that are implementing this yourselves, you would take things that whatever text that you're using, and the history of what they actually wanted, and that would be what you guys would use to generate your data to then load and do all that.
If that kind of initial data capture process involved like a PDF or a Word document, would it analyze that data as well? And sorry, and a second question, just in terms of limits, in terms of classes or the amount of text it can analyze for that initial call.
So I'm not going to remember the numbers off the top of my head, but my session tomorrow, even if you just download the slides, has a lot of what you're asking for. But the format for the file itself would be a CSV file. And there's other formats actually, but just come to the session and I'll go through all that. Anybody else? Okay.
Is there a recommended amount of data that you utilize to train your models?
It's a good question. So the answer typically in this space is it depends. It really doesn't help you at all, right? But there are some, prescriptive methods saying if you have so many dimensions in your model and so many different classes and the complexity of the algorithm you're using, the data should scale in a certain way. Honestly, in my experience, it's really been based on trial and error. You get a decent handful of data, you kind of partition some of it to train your models, and you kind of cycle through what you use to test it, and you see if increasing the data set larger and larger and using smaller amounts for testing actually improves your error scores or not, depending on whether and then you kind of plot out what they call learning curve and see if you reach to some level of stability. So that's probably, in my experience, what I found to be the most useful way of finding out. You've got to be very careful, right? Because in the end, the data you use to train is basically everything, right? If you have any kind of biases in data, which basically may end up corrupting the classification decision as you have. So in reality, what I've kind of experienced also, you launch off with the data you have, but in a way where in an actual implementation, whatever data you encounter, you use that to keep online updating models from time to time. So it starts to converge to a more holistic solution over time. I don't know, hope that answers your question to some extent.
Well, it does, and I have one follow-up.
Yeah.
How often do you retrain your model? Or is there a method where, as you do your initial preliminary training, that it can, become more artificially intelligent as more data sets get created? Or do you have to retrain the model every 6 weeks, every 6 months, every year?
What I would do usually is, depending on how much new data we collect compared to what we trained previously, right? So maybe, as an example, I'd probably say if whatever data set I had, if I have 50% more new entries, that's when I'll do one bulk update. I'll probably try that offline to make sure that what is done to my actual results on all the older results I've had, how they actually changed, and then decide if I want to use that data or wait till more data comes in. Once again, it's more of a it depends kind of answer. But that's, I think, the best that we can do in this space right now.
In Einstein Platform Services, they give you a way to keep retraining, right, programmatically. So in the lending network example that we gave, the leads would get routed, and maybe it's wrong, right? So once it gets to the lenders, they would then recognize that it was wrong, and it would be corrected just through our normal business processes. And then that would help us, because obviously going through the whole loan process, it would be corrected data, and we can use that data that came in to continue to train and improve our models. Go ahead.
So you need a lot of data for the training data set. Where do you take it?
For this example, right, and it's definitely an option to get started, is we found publicly available data on loan data. And it does have its own licenses that you have to be aware of, but you can certainly find and buy data that can help you get going. Also, really you want to look at your business first, right? So if I was a lending network, I would have all the leads that came in and all of that data, as well as what kind of loan it was. So I would use that data, the historical data I've got, to train my models.
Yeah. And just to add on to that, right, I mean, in our search for data, we found different kinds, like you said, different licenses. Sometimes there's licenses which are purely for academic and research purposes, which typically don't have any cost associated with them at all. I've seen licenses which are typically one step forward, which basically mean you can use it in commercial research development, but not for any commercialized product. Those are typically one cost higher, but then there's commercial licenses as well, meaning, okay, here's data, you may attribute where you got it, and then do whatever you want with it. Those tend to be more expensive. And it really depends on the data you're looking for. I mean, for example, we have a project going on right now where we're, in Illuma Labs, we're developing a technology to do authentication of voices on phone, right? So we need machine learning algorithms and data. Those data sets typically end up being in the $10,000 to $20,000 range if we buy enough of it, and that's talking about like 3,000 phone calls worth of data. Now, is that enough data for your application or not? That kind of may vary, but it is a large number, but I think personally sometimes it's cheaper to buy data than trying to go out there and collect it yourself, especially from an unbiased source.
Just one more comment, sorry. This website's a great place to start. So Kaggle.com, that's where we got our data, and they have massive amounts of data to use to try to, whatever your scenario is. Some of it you can buy, some of it you can't, but it's a great place to at least get started with.
Can you train your data on your child object to predict it under?
So the Einstein Platform Services is separate, right? It is a separate REST service not embedded within Salesforce itself. So, if you had objects in Salesforce that you wanted to use to train the data, you would simply write something that would output it to a file and then programmatically upload that file into the data set into Einstein. Anybody else? Did you say bulkify? Mm-hmm. So, and I think I'm answering your question. Let me know if I'm not. As far as I can see so far, calling to load your data, right? You're loading a file, so you can load large files. And in my session tomorrow, I'll talk about how to break it up, right? If you have a lot of records, you can break it up into multiple files, upload each one, and add more and more data, then train your model. From a calling point of view, like you've got your application that needs to do a prediction. That appears to just be a single, you can only call with one piece of data, not bulk yet.
Stop me if this is covered tomorrow, but is there a best method for testing your models after they're trained in here?
So I'll kind of say my stuff, and I think Nolan will have a better answer. So a part of this process on what I did is I think I had, it was like 100,000 records is what I downloaded here, and I used about 20,000 records to actually train my model, and then I had the rest of that labeled data to test with. So let's say you had, 20,000 records, from your historical stuff in your Salesforce org. So you could use, portions of that to train, and you would just make sure you're creating enough labels, right? So make sure you have enough for auto loans and home loans, and the amount of labels you have is decently spread out. and then use the rest of your data to actually validate that it's working. And when I started, I uploaded, I think it was like 5,000 records, and I saw my probability score, it was like 70-something%. And then I uploaded another 5,000 and it increased a little bit. So you can keep retraining and keep testing, and you'll see the probabilities go up or down to kind of help you fine tune. Yeah. Anything to add?
Yeah, I'd say, the way I've typically handled these is for the data set you have, in this case 100,000, let's say that example, right? You start off, and it'll be tedious, but I think this is one of the good ways I've found to go about it. You take a first set, maybe 20,000 samples for training, and the remaining 80,000 for testing, so 20%, 80% split, and then you randomly choose which 20% you want from the entire data set, retrain your model and test performance. And you kind of want to see if changing data has got you to a stable level and maybe find average results for what you get with that set of data. Then you increase that, maybe go to 25 or 30,000, sample 25, 30,000 as training randomly from the entire set, and then look at the average results. So that kind of protects you a little bit from accidentally picking up biased data, but also lets you see, taking more and more data, at what point does your system actually converge. You should get to a point where after a certain amount of data you've trained it for, it'll stabilize, and in fact, it might actually even get worse with more data. That's something that you'd experience, I'm sure. And that sometimes can be solved by, if you're overtrained your model, it's one indication to let you know if you've gone there. But usually, in my experience, if you go more than 80% of data to train, to basically train your models and have less than 20% to test, you're kind of getting to a very small amount of validation data to begin with, where it may not make sense anymore. So if you're seeing performance improve all the way to that point, the next task would be trying to find more data that you could work with.
All right, guys, so we are out of time. Definitely appreciate that. If, here's our contact info if you have any other questions. Feel free to come to the session tomorrow to learn more about getting data in there, and thank you for coming.